Hello everyone, today I will introduce the Pac-Man, a Q learning based game project. It's cleverly combined the classical game with Q learning algorithm, bring a brand new experience to both players and the developers. Pac-Man is similar to the classical uh, Pac-Man game. In this game, the player have to control a basketball elf named Man to evade the chase of a group of cute enemy called Kun, while collecting all the corn on the map to complete the level. Uh, it sounds really like the Pac-Man. This project is developed using the Pygame library and integrates the Q-learning algorithm uh, in enabling game creators to continuously learn and optimize strategies to achieve the goal of completing levels and obtaining high score. This project is developed using the Python language and mainly relies on the several important libraries. The Pygame library is used to build game interface and handle game logic. The NumPy library assists in the numeric calculations. The matplotlib library is used for visualizing training result. The PyAuto GUI may be used to simulate some operations. The Pickle library is used to store and read the Qtable date. The next part is code structure explanation. The first one is spirit.py. We can see I defined the wall class, the food class, actually it's corn. The player class, it contained enemy and the players, but it's all called the player class. And the change speed function and the update function is update the location of the players and the random direction. This field define the spirit class. Uh, this class contains information about the appearance, location, and the interaction roles of the spirit, which are specific uh, manifestation of game elements at the code level. For example, the player spirit class specific the movement of the player spirit and collision rules with other elements. And the next one is the levels.py. This field is responsible for setting the game levels. Uh, we can here we can see the level one, the initial, the setup walls, and the setup gauge. Setup player is contained the hero, the Kun, and the hero, the man, and the ghost, the enemy, the Kun. Here, the parameter and the setup food. Actually, it's corn. Uh, Actually, I can say different level may have different enemy movement uh, strategies and the map layout, which increasing the fun and challenge of the game. But actually, I only made one level here for the Q learning. Maybe I will try some new level or some new map in the future. The next one is May.py. This field. Uh, it's the main entry field for the project, but it not contain the Q learning part. It uh, mainly responds for initializing the game environment and game logic, allowing the players to directly get start playing the game. After running this field, the game window will pop up and you will see the initial interface of the game where you can use the keyboards control the movement of the main elf through the up, down, left, right on your keyboard and evade the chase of the queen enemy and collect as many corn as possible. The goal is collect all the corn on the map, and you can complete the level. Here we can see. Let's start the game. Oh, uh, oh, oh! You can see I'm really not good at this game. It better let the Q learning algorithm to control the elf. Uh, the next one is the QLearning.py. This field is the core field for implementing the Q-learning algorithm. It is responsible for handling Q-learning training and will save Q table at certain intervals. During the training process, the algorithm will continuously update the Q table to optimize game strategies. Here are several important Q-learning parameters involved. The alpha is the learning rate. It controls for the degree to which new experience affect Q value updates. Setting it to 0.1 means that the new experience will have a certain impact on the Q value, but we will not completely overwrite the old experience, allowing the model to maintain a certain level of stability during the learning process. The next one is gamma. It's the discount feature. The the importance of the balance immediate immediate rewards and future rewards, setting it to 0.9 indicates that the model will future long-term rewards more and consider the impact of correct actions on the future status. And the next one is initial epsilon. Mm, it determines the probability of the model exploring during the early stages of training. Setting it to 0.9 means the beginning of training. At the beginning of training, the model have a 90% probability of randomly selecting action for exploration and exploration decay value. As the training progresses, the model needs to gradually reduce the exploration probability. This value represent the magnitude of the decrease in the exploration rate during the early decay. And the next one is a minimum exploration rate to avoid the model falling into the local optima. A certain exploration probability need to be retained even in the later stages of the training. This value is a lower limit of the exploration rate, and the exploration rate decay interval it indicates how many training session will decrease the exploration rate. Meanwhile, the reward the reward computer mechanism is a key component of the Q-learning algorithm, guiding the model to learn the optimal strategy. And the collision. And here are some reward. You can see where. Oh, here, get reward. Mm. And the first one is the collision with a ghost. When the player control the basketball hit a ghost, uh, they will receive a reward of minus 100, promoting the model to avoid such deadly uh, collision as much as possible. And eating food. Eating food can earn 10 rewards, uh, encouraging the model to collect more food. And successful successful completion. Successful complete the game will earn an additional reward of 2,000. It's really high, uh, motivating the model to uh, complete the level. And the punishment for eating beans, not eating corns. Mm, if no corn are get within a certain number of steps, there will be a minus 10 minus 10 rewards to prevent the model from falling into a state in of inactivity inactivity and exceeding the maximum number of steps. Uh, this parameter is avoid the agent keeping moving uh, keeping moving in the corner of the map and don't eat the corn anymore. Mm, uh, when they keep moving in the corner, it may get minus one, and don't eat corn for a long time, it may get minus 100 negative reward. And the other situation, for other situation, a small plenty of minus one will be given to encourage the model to take effective action. And the next one is the load.py. This field is used to read the Q-table field and evaluate the training result based on the two indicators, the uh, the successful rate and the score. Finally, the result will be represented in the form of a line graph for us to understand the train effect. Now let's run the code. First one is cd dot get into the and then run this one. Oh, it's catch. Um, Due to the limitation in device performance, it has only been trained 350 times so far. During the training process, we found that the training speed are very slow. Based on the correct training situation, it estimate that maybe 5,000 train sections will be required for the model to success complete the game. However, I saved the Q table field from 50th to 350th training section to for us to see the result of the training. Uh, we just read the Q-table field of 50th training result and view the evaluation result by running that code. And if if you want to view the multiple training result, we can run this code. It will run the 50th to the 350th the PKL. Uh, uh, After running this code, the corresponding the plot will be generated. Uh, we need to wait for some time. Oh, it don't move. As what I just said, if it don't move, it will get punished. But actually, it's load, so it don't get punished. But if it stop too long time, the game will just failed. It's also a kind of punishment. Oh, you can see the basketball run faster than the first 50.pkl. It really gets smarter and smarter. Oh, much more clever. It gets more, really more score. Here we can see the score line of a scoring chart turn upward, uh, indicating the training effect is good and the model gradually improve the scoring ability through learning. But the training speed actually is still very slow. And this one is the winning rate is always zero due to the insufficient training. But we have reason to believe that with more training, the model's win rate will improve and the better result can be obtained. Okay. Uh, the above is the complete introduction to the Man project. This project perfectly combines the classical gameplay with the Q learning algorithm, allowing both the game enthusiastic and developer to discover many areas worth exploring. I hope everyone can personally try it out and feel it charming. Okay, thank you everyone.